Hey guys, I am Raouf Teloni. I am a PhD in mechanical engineering. I will be your host during the additive manufacturing course. I hope you will gain the knowledge that you expect from this course and you will be able to apply the knowledge that you have in the real world. And I hope as well that you will have some fun during the course. For now, let's head to our course. Additive manufacturing is the opposite of subtractive manufacturing. Instead, as we know, subtractive manufacturing, instead of removing the material from the object in order to create the final product, in additive manufacturing, you are adding specific material for a certain object in order to create the final design needed. The formal definition of additive manufacturing is a process where you convert your 3D design into a real product by depositing several layers of material in a programmed way. Again, the famous name of additive manufacturing, which is known in the market and known by most people, is 3D printing, where you emphasize by saying the word 3D printing, you are differentiating between the additive manufacturing and the material removal methods that are traditionally known. So 3D printing again is a process where you make your 3D dimensional object from a digital design into a real life product. In this way you are doing 3D printing. We are seeing a more general term, which is additive manufacturing, because you are adding layers of material above each other until you create your final product needed. If we want to define how does the 3D printing work, firstly you go to your CAD software and you design the object you need in the dimensions you want. Then you do something either embedded in the software you're using or in an outsourced software. You're doing something called slicing, which is basically defining the solid objects that you designed into specific group of layers. These layers helping the program to generate a code for the 3D printer to follow in order to do the layers one above each other to create your final product. When you finish doing that, you just send your order to the printer and you wait for your part to be ready. We can see here there's a visualization of the 3D printing process. So you can see here, using your PC or laptop, you create a 3D object using a CAD software. Then secondly, you send your CAD data into the 3D printer. Then eventually the printer will start doing the 3D printing for you. So we can see the base here have a linear motion where it can go in the axial direction, while the nozzle, the one we see in here, can move on X or Y directions in the front plane. So it can move either in the X direction or in the Y direction in this case. So either on the X direction or on the Y direction in order to create your final product needed. This is another illustration of it's a sketch for the way the 3D printer work. It doesn't show a lot of engineering details in it, but it's showing you that the nozzle and his related assembly are moving in X and Y direction, while the plate where you deposit your design is moving as well. In some designs it's moving in the Y direction in order to create your final product. So the benefits of using 3D printing: firstly, you can create a product based on your personalized design. So your products can be personalized based on the design you exactly want and based on the color that you want in some cases. Secondly, the ease of access for everybody. So, if you can easily own a 3D printer and put it at your desk and print whatever you want, anytime you want. Or you can even If you don't have it, you can talk with outsource companies who can create the product for you. The moment you have the design ready with the file format needed, then you can just create that product easily. Thirdly, you can create even very complex parts. As we know in the subtractive manufacturing, sometimes you have mechanical limitation on what kind of designs that you can make it reality. But in 3D printing, you can create complex parts with no problems. And then you can reduce as well the tools that you use. Then how much tools do you need to create a certain part? Again, subtractive manufacturing, you need a lot of tools and a lot of efforts to put into the machine in order to create a final product for you. But in this case of 3D printing, you can just reduce the tools that you use. Just basically you need a printer that will print specific part for you with the specific materials, with no kind of specialized material to do that purpose. And finally, it is considered, as a 3D printer, considered an eco-friendly process where you reduce the amount of material that you use to create your final parts. Again, as example, it's not a subtractive manufacturing. There's no material that is being eliminated or sent as a disposal after the process. All the material that you use is the material that you need. The application of 3D printing you can find, as we will discuss in details more later on. There's many applications that are using the 3D printing technology, basically same as industrial parts, so that they can early evaluate their products. Like in the industry, when you go do some work in engineering companies, they are designing a new product or even a part that needs to be a part of a big assembly in a certain application. Before they go ahead and do this actual product, they can do 3D printing to evaluate if this product is fitting their needs in terms of size, dimensions, and even in terms of design. Secondly, you can do architectural models where you can see, if you are in the architecture field, you can see your prototype of design in real life. So in this way you can inspect it in a better way, and you can have a better visualization for that product before you go ahead and make a real building out of that design. Thirdly, you can, as a customer, you can do your own personalized parts, as we said, in terms of dimensions, in terms of design and color. And as well, one of the important applications for 3D printing is in medical applications, either in body parts replacements or even in protective purposes for medical applications. Again, the basic principles of additive manufacturing. Firstly, you create your 3D design using computer-aided design software. As we can see here, this kind of design is created using SolidWorks. So you go, if you ever got a training on how to convert 2D to 3D designs, you can easily recognize that this part is being converted from a sketch or a 2D design into a 3D design, and it's ready to be printed. So the next step is doing a slicing. So you slice the part into two-dimensional planar layers so that the printer will be able to identify them and do mapping for the printing process. We can see here on the left, this is the designed solid part, and this is the embedded slicing process. So you basically depend on the slicing algorithm. Either you're slicing the part up, down, right, left, right, etc. The solid parts is sliced. So your solid part is sliced into planar layers that can be mapped and identified by the 3D printer, and these layers, they will go above each other to create your final product needed. In order to do the slicing, The modern softwares, luckily, they already have the slicing process. Most of them have the slicing process embedded inside of them. But in the previous times, when the additive manufacturing technologies and 3D printing was early in the market and new, so the engineers or the hobbyists by that time who are interested in 3D printing, they were using slicing softwares that are outsourced other than the 3D design software. These softwares, as we said, convert the solid part into a group of sliced layers where it can be identified by a 3D printer and achieve the final product. Eventually, you just send your part into the 3D printer. If the 3D printer is at your desk, you can just basically click on 3D printing using your 3D design software, and the printing process will start directly to implement the part needed. In some cases, you don't have the 3D printer at your desk. You need to send it to somebody else as an outsource, somebody who do it for you, or the printer you have doesn't have the properties that you need out of your product that you want to design or that you want to print. So in this case, you just send it based on what the what kind of file format the outsource need. You just send it to him accordingly, and he'll be able to produce that part for you. As we can see in this picture, for example, if you want a prototype for a certain structure or product, you can just basically design it using the computer, then send the order to your printer, and you're able to have that product with some kind of post-processing. Now let's talk about the existing 3D printing methods. So if you want to translate the 3D design to layers so that you can make an object, the printers need kind of coordinates. So the whole point of slicing is to map the 3D printer. Mapping means you are coordinating the 3D printer nozzle to go to certain points in the space and deposit the 3D printing material. So the most common printers, they use the Cartesian coordinations, which is the XYZ, as we can see on the right hand side in here. So in the Cartesian method, most of the printers use that kind of coordination, where the objects and dimensions are known based on points in the space defined by XYZ. These points are based on the slicing process. They are mapped in a certain sequence to produce your final part needed. There's other kind of coordinates that are being used for 3D printing, similar to the delta and the polar coordinates. These coordinates produced new types of printers that they have their own cons and pros. So if we look here on the top picture, we can see a delta coordinate 3D printer. It's basically relying on the mechanical linkage. As we can see, there's 3 mechanical linkage driven by servo motors. They go through stretching these linkages in a certain sequence and a certain program to be able to print the part in the space. The good thing about this printer that although in the XY direction, like the width of the part will not be any different than the regular 3D printers, but the height could be different because in this case you have more height than regular 3D printers in case that this application is fitting your needs. If your part is tall, then in this case this kind of design could help you. The second one is the polar coordinate based 3D printer. As we can see here, this printer is basically having a base that rotate on a certain angle, and you have the nozzle here who rotate and moves. It moves on the Y direction, and at the same time it rotates so that it will have a space based on the polar coordinates. You will have a point in the space where you need to drop your 3D printing material and create the object. overview of the 3D printing. So 3D printing is going through three main processes: additive processes, lamination, and solidifying processes. The additive processes, they have a process called fused deposition modeling, and you have the multi-jet modeling. And solidifying processes, you can have either the selective laser sintering, selective laser melting, or the stereolithography. Each one of these 3D printing methods will be discussed in details during this course. Again, another overview of the additive manufacturing processes. You can have a different criteria for the 3D printing sorting. You have either powder-based, solid-based, or liquid-based. So the liquid-based can be sorted by melting or polymerization. Melting is similar to the FDM method. Polymerization similar to the SL and the PolyJet method. Solid-based are similar to the LOM. Powder-based, you have either melting or binding. Melting is similar to SLS, ABM, LENS. Binding like the 3DP and the Pro Metal. Now let's start talking about the stereolithography, one of the main important 3D printing processes. It's an additive manufacturing process, works by a laser which is focused on a certain area of a photopolymer resin. As we can see in the illustration, we can see here there is a laser going through a laser beam and reflected through an XY scanning mirror on a bed in here. So inside this bed there is the liquid photopolymer. It's a kind of container that's having a liquid inside of it, and there is a build platform which is a base. This base can go up and down based on the 3D printing program as needed. And we have here a sweeper which can sweep any kind of additional material that's not needed on the surface. So the laser comes in here on the liquid. The points where the laser is projected are carefully programmed to replicate what is the needed design is based on the, so it takes layer by layer based on your 3D design and based on your slicing process. So the laser is projected layer by layer, then the sweeper will, after the first moment where the laser is projected on the liquid photopolymer, then the liquid photopolymer will solidify. It will move from the liquid state to the solid state. There is some kind of powders or particles by that moment, so the sweeper will sweep these extra material away from the surface. Then this base will move, it will move down. Again, it's in a calculated manner. It will move down to be able to create the next layer, and this process keep going until you start to form your part. As you can see here, the build part is being done and it's getting almost to get finalized by the last couple of layers to be finished. Then the product will be ready to be provided to the user. So the word stereolithography, it produced the standard 3D printed object file type, which is known as the STL. So the 3D printers and software until today, they're still using the STL file type for most common printing operations. So what is STL? STL is basically stands for Standard Tessellation Language. So this kind of format will help you approximating the surface of the solid model with triangles. It's trying to do kind of meshing process. So the surface of the solid model that you design is mapped into 3D triangles to be able to map the surface of your object. So in most of the CAD systems that are used today, they are capable of producing an STL file. Just basically you go File, Save As, STL, any 3D design software in mind. Mostly they have this this kind of file extension that you can use. So the concept of stereolithography, it uses a focused ultraviolet light that transforms the liquid photopolymer plastic into solid. So photopolymer is a polymer that's sensitive to light. When you expose it to light or laser, it will be solid. We can see in this case, again, same as what we explained previously about the stereolithography. You have the laser, you have the scanner system, then the laser beam will go down here, and you have here the container which have a liquid resin photopolymer. Then you have here the piston which moves the base up and down based on the solidifying process up to the point where your final product is ready. So what is the photopolymer? As we mentioned previously, photopolymer is a material that can transform from liquid to solid in no time when you produce a certain light or laser on them that carries some kind of energy or heat. It will move it from a liquid state into solid state with no time. The good about stereolithography is it can produce an objects or parts which have great or high details. As we can see in the part in here, this is a part produced by stereolithography process. Again, the stereolithography as well can be enhanced to produce a high resolution products and small dimension products which can be up to the microscopic size. It's called the multi-photon lithographic designs. These designs can create the entire building and be very small. As we can see here, the part we can see in front of us is only 20 micrometers in dimension. So this part can easily be lost in a drop of water, which is a good side for stereolithography in case your application needs an object that's in the macro dimensions. Another system that uses the photopolymerization is the polyjet. The polyjet basically uses the inkjet material to build the layers, and the system doesn't rely on a bath of liquid or a container of resin, but it instead keeps the material inside the cartridges that he have within the printer during operation. Then he makes the material while it's being sprayed. So the material in the cartridge, material will be mixed during spraying. Then the spray will be hardened using ultraviolet light after each pass of spray. On the right, you have the source of ultraviolet light. Then you have the build tray. You have material A and material B. They are being sprayed, and the ultraviolet light passes to solidify that material on the go. So the mix of material happens in the air or on the go to allow for the creation of different functionalities within the same printed material. Basically, the material will move from liquid spray into a solid material that is related to the design that needs to be produced. The other method we are going to talk about is the digital light projector, abbreviated as DLP. By the way, we will be using a lot of these abbreviations during our course because they are long names and it's more convenient to have these abbreviations, so keep these abbreviations in mind if possible. Digital light projector, as we can see in the graph, or as we can see here in the illustration, so it's basically you have a light source, then you have a digital light projector, that's why it's called DLP. This projector will reflect the light through the lenses. Then the lenses will go to the photopolymer that's sensitive to light and produce a certain layer, and the process will repeat based on the design. And these motors, they will be moving the stage, the part here called stage, they will be moving it up and down in the Z direction as needed to produce the final product. So the properties of the DLP process, it uses liquid ultraviolet photopolymer resin and solidifies one layer at a time, same as all kinds of most kinds of light dependent 3D printing processes.